Okay, so let's say that we've been given the linear equation y equals 3x minus 1, and we're asked to decide whether or not a given ordered pair is a solution of that equation. So let's say that we're given the coordinate 5, 14, okay? So our x value of this coordinate is 5, the y value is 14. If we were graphing this on the coordinate plane, we would go positive 5 in the x direction, and then positive 14 in the y direction, then we plot that point. The question is, would that point be on this line? Okay? Well, we can check that simply. We know that the 5 stands for the x value and the 14 stands for the y value. So we're just going to put 5 in for our x and see what we get out as far as y is. So when we evaluate this for x equals 5, we have 3 times 5 minus 1, and that's going to tell me what my y equals when x is 5. Well, 3 times 5 is 15, minus 1 is 14, so I get that y equals 14, and again, that's when x equaled 5. So that tells me that this ordered pair is in fact the solution of this linear equation. Okay, this time we're going to be graphing a linear equation using a t-chart. Okay, we've been given the linear equation y equals 2x minus 3. Again, linear because it describes a line, and we're going to try and come up with what that line looks like. So using a t-chart, which is aptly named because it looks like a t when you start with it, we're going to put our x values on the left and our y values on the right. It's always good to grab some negative numbers and some positive numbers to plug into your system. And again, the x is called the independent variable because we can pretty much pick whatever we want. And y is called the dependent variable because its value will depend on what x we put in. And these solutions will give us some coordinate points to plot on our graph. So we're going to evaluate this function at these 5 different x values here. So when x equals negative 2, I will get y equals 2 times negative 2, which is going to be negative 4, and then minus 3, which is negative 7. So I'm going to have a y coordinate of negative 7. So my first point that will be on my graph is negative 2, negative 7. Now similarly, when I go down here, 2 times negative 1 is negative 2. Minus 3 is 5. So negative 2 minus 3 is negative 5. Okay? When x is 0, I get 2 times 0, which is 0. Minus 3 is going to be negative 3. All right? When I plug in 1, 2 times 1 is 2. Minus 3 is negative 1. And finally, when I plug in x equals 2, I get 2 times 2, which is 4. Minus 3 is going to give me positive 1. Okay? So now if I were thinking of this on a coordinate plane, okay, we'll have our x-axis and our y-axis. Okay? And now we come out, let's say 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And because I see this negative 7 value, I'm going to go a little lower here. 1, 2, 3, 4, 5, 6, 7. And I'm simply looking at these at the points they describe. So negative 2, negative 7 is the same thing as telling me the point in coordinate form would just look like this. So I would go over to negative 2, so back 2 on the x, and then down 7. And I'm going to be at this point on our graph. Also negative 1, 5. So I'll be over here. Okay, 0, negative 3. Then 1, negative 1. And then finally 2 and 1. And, provided I did my spacing pretty well, which I look to have done all right with, we should be able to connect these dots and form a straight line. Okay. That would be how to graph this function using a t-chart. Let's say we've been given yet another linear equation, yet this time we're being asked to graph using the slope and the y-intercept. Well, as we learned in this section, when y equals mx plus b, or we're in that form y equals mx plus b, we call that slope-intercept form. It's named that way because it gives us the slope and the y-intercept just by visual inspection. We don't have to do any sort of arithmetic or anything to figure that out. So when I look here, y equals mx plus b, my m, whatever the coefficient on x is going to be my slope. And then the b, the constant that's sitting on the end of that expression, is going to be my y-intercept. Together, when I throw the whole equation, it's going to describe a line. In other words, the infinite amount of points that solve this equation. Okay? We've seen how to do this with a t-chart, but what we can do is use our understanding that when x equals 0, we know we're just going to be left with that constant. Because 0 times x, whatever x is going to be 0, and I'll be left with y equals b. So no matter what, when we have this form, our y-intercept is immediately available for us, sitting as the constant on the end. So when y equals mx plus b, and I look at this case over here, I have y equals 1/3 x plus 2. The place I'm going to begin, that's how I remember the b, beginning point. If I ever get confused where to start, I think b, beginning. All right. So here I have a plus 2. Okay? That tells me now that my y-intercept is 2. And again, it's because if x was 0, 1/3 times 0 will give me 0, plus 2 is 2. So that's going to give me the point right here on the y-axis. That's why it's called the y-intercept. That's where it intercepts y. Okay? Is going to be 0, 2. Now I'm going to use the idea of rise over run, or change in y over change in x. Okay? What my y changes relative to my x, well, it looks like I'm going to go up 1 with y and forward 3 with x. And remember that I could also have the negative version of that, which would be down 1 in the y direction, but back 3 with the x. Either way, these are equivalent fractions. We usually won't write a negative over a negative, but as far as graphing, that can be useful. So from my point that I began at, my y-intercept, I'm now going to go up 1 and forward 3 to the point 3, 2. And now I can also go down 1 and back 3. Okay, down 1, back 3 should put me over here. And now I've got 3 points. When I connect these dots, it's going to give me, let's see, right about there. It will give me the line that satisfies the equation y equals 1/3 x plus 2. So let's say this time I've been given a graph and I'm asked to put it into an equation form that describes this line. Well, again, we already know that we want y equals mx plus b, where m is the slope and then b is going to be my y-intercept. So I'm going to try and pull that from this graph to begin with. So the easy one to see is, what's my y-intercept? Well, it looks to me like I go through that graph where y equals 3. So right away I know that my y-intercept over here is going to be equal to 3 in this equation. And now comes the slope. Now remember, when we read this left to right, if we're going uphill, that's a positive difference. So we would call that a positive slope. When we're coming downhill this way, it's a negative slope. And then of course right in the middle of positive and negative, so if I'm not going down, I'm not going up, I'm flat, that's when we have a 0 slope. So just like a number line, there's still that relationship. So any horizontal line is 0. If I'm going up, it's positive. And if I'm coming down, it's negative. So immediately when I look at this, I know I'm looking for negative. And again, we're thinking rise over run. So when I look at this, I can see, okay, I actually go down 1, 2, and forward 1. So I go down 2 and forward 1. Okay, that's a negative 2. Now I've heard people ask me, well, wait a minute, what if you go from this point to that point? That's fine. In that case, I would actually go up 2, but then I go back 1. So I'm still at a negative 2 either way. These fractions are in fact the same fraction. They both describe negative 2. Okay? So now I know what my slope is. The slope is equal to negative 2. My y-intercept is equal to 3. Now I'm just going to plug this in. So m will be negative 2. B is going to be positive 3. And therefore the equation of this line is y equals negative 2x plus 3. And now I have the equation that would describe the infinite amount of points that we've collected to make up this line.